I'm Mr. Green Christmas. I'm Mr. Sun. I'm Mr. Heat Blister. I'm Mr. 101. They call me Heat Miser. Whatever I touch melts within my clutch. Psst. I'm too much. These are the past 24 hours from Solar Dynamics Observatory. Here's a different wavelength. 304 angstroms. And by the way, we want to know if you are complete with your elfin duties. Have you completed your elfin duties, folks? We want to know. Let us know in the comments. If so, we've got mostly stable sunspots since yesterday. A little bit of evolution of this group. Besides that, mostly stable. This group right here did feature some recent motions. Not a lot of changes going on. We do have a rising likelihood of large solar flares in the western limb. So watch that western limb. There are also a few magnetically complex sunspots showing up here, but the most likely spot would be that western limb. And check it out. It looks like we have some aurora over Iceland. So it's very green up there at Hekla right now. Also some apparent purple there. So it looks like some purple and some green aurora happening there. And let's just hit a quick refresh, see if we see any more likely aurora locations. I don't think so. It looks like the Reykjanes volcano has stopped erupting, although there is indication that there is still some magma flowing around there, although it's been staying underground. Different hazard zone map has been drawn. And here are the rest of the volcanoes that are erupting. Abico producing a 17,000-foot ash plume there. Mayan, unknown ash plume from Mayan, 10,000-foot ash plume over Ibu. Luwatobi producing an 11,000-foot ash plume. Merapi, 18,000-foot ash plume. Flight level 180. Flight level 190 over Popocatépetl. In central Mexico, Santiaguito mildly exploding. Please do not pole vault the caldera. Fuego in Guatemala exploding. 15,000-foot ash plume. Nevado de Ruiz in Colombia exploding. 21,000-foot ash plume. 25,000-foot ash plume over Sangay in Ecuador. Sabancaya exploding. Flight level 240. And check out our Ask a Particle Physicist segment. So today's was a question once again submitted by me. And by the way, if you want to submit questions yourself for our Ask a Particle Physicist segment, you want to ask a question to the monotone from Minsk, Eugene Bagashov, just head to our forum, smashomash.com/forum. It's entirely free. And just head to the General Science Forum and click on that, and you'll find the Ask a Particle Physicist submission portion. Here is today's. Normally these show up on a Friday, by the way, but today we're doing it on a Saturday because I took a day off for once yesterday. Here is our Ask a Particle Physicist segment.
So the question I have today is, do CME cause volcanoes, and if so, how? Well, first of all, I assume what was meant here are volcanic eruptions and not volcanoes themselves, because it's kind of hard for me to imagine how CME can cause a volcano. However, I gotta remind you that I've got this paper with Jacob Gable where we show how craters might appear from a very strong CME, and we're talking about like a CME we've never observed in reality, okay? But hypothetically, if there was an incredibly strong CME, this could have caused cratering, and who knows, maybe even volcano formations. But that's like, hypothetical land. If we're talking about today and about the eruptions of already existing volcanoes, then I don't know. Like, my short answer is probably no, they don't, because that would be pretty easy to show that there is a correlation between some sort of volcanic indices and CME arrival, but I am not aware of these studies. I mean, maybe you can find them, these correlations. I mean, but well, go ahead and do so then. Like, I haven't heard about this, but maybe it is. Maybe you can find it. Like, if we just hypothetically assume that this is possible, what can we say? Well, CME do modulate the cosmic ray flux, right? So, because they have an electric field, they can accelerate cosmic ray protons either towards or away from Earth, right? And we do know from some previous studies that, at least hypothetically, cosmic rays modulate magma viscosity, which means there is at least some channels of influence of CMEs on volcanic eruptions, at least through this effect. I'm not sure how important it is. I'm not sure like how reliable, replicable it is, because again, all these, like sort of catastrophic processes, they're like a lot rests here on various chaotic processes, on like, accumulation of tension and things like that, which is not very predictable, I would say. So I doubt you can find some sort of straightforward correlation. All right, so it's more like a, like a stepwise function. It's like stuff accumulates, and then something happens. But that's my view of it. I might be wrong here. So this is one channel of influence. Another channel of influence is some sort of inductivity through the current systems around the Earth, right? Because CME, what does it produce? Well, this extra plasma, it feeds currents in the Earth's magnetosphere, the ring current first and foremost, which alters the magnetic field of Earth. And the inductive connection of the ring current to our magnetic field, to our telluric currents in the crust, that might be another channel of influence of CME clouds on various magmatic processes and whatever geological processes. But I haven't seen the people studying this in too much detail, so it's all hypothetical. It's all really, really poorly studied. But I would say, like, I see two possibilities. Basically, this one, when we modulate particle flux with the CME, and the second one, we modulate currents with the CME, the currents in Earth's magnetosphere, and therefore the currents through the crust and the magnetic field itself, etc., etc. So that will be another channel of possible influence. But as I've said, like, no real studies have been done on this subject, at least the ones that I'm aware of. Yeah.
So there you have it. That is the answer from Eugene about whether or not CMEs cause volcanic eruptions. And of course, there may be some realm of influence there, but to suggest that CMEs cause volcanic eruptions does not seem to be like a valid statement to me. I don't know. Tell me if I've misstated this. But make sure you subscribe to Eugene's channel, Eugene the Philosopher. Check him out on YouTube. Check out all of his videos. He's also got a Patreon where you can get additional content, get some early releases. And again, if you want to contribute, head to the smashomash.com/forum. You'll find the General Science Forum right there. Ask a Particle Physicist segment. You can submit questions of your own. Next, moving on to seismic activity for the past 24 hours. And what do we have going on? So there are the past 90 days for you. And here are the quakes that have happened for the past 24 of a 5 or greater magnitude. A 5.2 at Tonga starts out our list at 22:57 yesterday. And then a long period of no 5 or greater magnitude quakes. Well into today. There's late morning, and 1422 we had a 5.3 at Philippines, and then a 5.2 at Philippines, and then a 5.7 at Russia on the Kamchatka Peninsula there at 1748 Universal Time. And then Vanuatu had a 5.2, and those are the quakes of a 5 or greater magnitude. And here is some more solar imagery. Here we've put together the SDO 304 angstroms once again, but we've added the 193 difference imagery on there. The running 60-minute difference. So it gives you a little bit better contrast of plasma motions and so on, showing two different wavelengths, one on difference imagery. Maybe that helps you see what's going on there. I'm not sure, and we'll be showing more of this in the future, by the way. And next is the radio flux, which is now down to 174 solar flux units. 174 is the new radio flux number. There is the 1-year graph of the radio flux depicted by the black line, not updated yet, but it will be 174 will be the next update there. And sunspot number here remaining over 150. We'll get to that in a moment. First, the NOAA forecast there. No space weather storms in the forecast. It is geomagnetically calm for the coming days through Christmas. Next is the Earth's magnetic moment from space. Here are the past 4 hours. And again, we do have geomagnetically calm conditions now. However, there are some undulations. There are some separate solar wind regimes coming in here at the same time, producing a bit of a sputtering effect, which is the undulations you'll see there in the magnetohydrodynamic pressure depicted by the space weather modeling framework. Here is the ground magnetic perturbations map. The past 4 hours of magnetic flux density on the surface of Earth. Changes to Earth's B field, geospace delta B, is what the space weather modeling framework is modeling there. KP index currently at 1. KP1 is the geomagnetically calm situation. And here's a solar wind we were talking about. Now, the ACE doesn't show it as well. There are two separate regimes showing up right now. The Discover shows it much better. You can see two different plasma temperatures and two different distinct plasma velocities. They're about 150 kilometers per second apart. So here's the faster stream, which is a little hotter plasma, as you can see by that green bar at the bottom. About 478 kilometers per second. The cooler plasma is 348 kilometers per second. So different plasma temperatures there, different speeds, and different densities. So again, two different regimes there. That is a sputtering solar wind. Different temperatures, different densities, different velocities, different magnetic fields. Current conditions are about 450 kilometers a second for the speed, solar wind density about just under 6 protons per cubic centimeter. GOES magnetometers here pretty smooth, no geomagnetic storms, no surprises there. Some arcjet moments yesterday. And here are the top view ecliptic plane field plot data. And Earth has just recently snapped into a South Pole sector. There you can see that South Pole sector depicted in red. Along with stereo B, stereo A will be snapping into that South Pole sector in an hour or two. Here's our ecliptic plane line of sight field plot. Things are looking a lot more stable in the east now, so things will be a little more predictable on the eastern limb according to that. Keep in mind the magnetic data gives us great predictive value, folks. We've demonstrated it time and time again, probably hundreds, if not thousands of times on the channel. Next, our line of sight field plot, and one of the best summaries of what's going on with the sun. Quite a bit of magnetic organization on the Earth-facing portion of the disk. That's what happens when you have over 150 sunspots. Last but not least, our line of sight coronal hole plot. And of course, in a South Pole sector, you'd expect South Pole-oriented coronal holes, and indeed, you have them. So there you go, South Pole coronal holes here mostly, except in some select locations. So we've got These are north right here. These are north. And the rest of these are south pole coronal holes. Pretty easy there. And let's move to sunspots. I'm sorry, sunspot number just dipping slightly below 150, but still above the current average of 130. So sunspots are currently at about 145. 145 sunspots according to Rob, the Royal Observatory of Belgium. Next, solar flare probability scoreboard. And nothing. Just solar flare probability and scoreboard. Like I said earlier, we have multiple magnetically complex sunspot groups. In my opinion, the most likely place to see a large flare is now 3528. As it gets closer and closer to the limb, 3528 and maybe even 3532. Next in line would be some of these other groups, like this one here, this one here, this one here. Those all have some magnetic complexity, but again, the western limb is the most likely place to see a large solar flare. Here's SDO continuum. And the most action has happened in this group right here. A little bit of umbral migration there at the end. There's the past few hours have featured one of those umbrae rushing off to the north. And let's move on to energetic particles and flares. No spikes in the proton flux, no energetic particles. Flaring has been diminishing here, so the X-ray flux has been dipping along with the radio flux and the sunspot number for the past 2 days. And let's move on to, there's 94 angstroms from SDO. Again, no major flares here, only C-class background flux and C-class intensifications. The T-mass has been this sunspot right here, so that is the most active sunspot. And here's a star chart. I want to see what's going on over my head, so I like to use skyandtelescope.org's lovely star chart. There it is, skyandtelescope.org. Just put in your location and press the Now button. Now over our head we've got the Moon and Jupiter, also Saturn up there, closer to a setting mode. Here is our solar system forecast. That is where things are today. Here it goes, the 1 week forecast. That's where things will be on the 30th as the year runs out. To quote Eugene the philosopher, the eons are closing. Next, our astronomy photo of the day. And guess what's at the center of this? Polaris. Yeah, it's the North Celestial Pole. And I can't remember where that took place, but it shows the aurora and some star trails. It's time-lapse imagery. Obviously, it's located at somewhere. Some location. Milky Way galaxy. From New Zealand. Oh, I'm sorry, Southern Hemisphere. It's not Polaris. It's whatever the South Celestial Pole is. Anyway, moving right along, that's the astronomy photo of the day. Here are CMEs. It's time. Time to check on CMEs. Are you spooked? Don't be spooked. They are very unlikely to end civilization. We do have another sun-diving comet, by the way. So those are CMEs from yesterday. I don't see anything looking earthly directed. What do you think? Let us know in the comments if you agree, disagree, are neutral. Leave us a comment if you don't even care. Here are today's CMEs, another 84 frames. And we've added the C3 here, which is shown in blue. And you can see that comet making its way in from the southeast, which would be your lower left. Here's a little more zoomed in view. Comet right here. And what the heck? Let's take a closer look at that. Is it my imagination, or is that comet taking a zigzag path? That is pretty weird. Let's advance that. That comet looks like it is zigzagging. Check it out. Very strange. What is up with that? Just bizarre. All right, I'll play that through one more time. The comet is right down here. Tell me if that looks like it's flying a straight path to you. Maybe it's tumbling and hence outgassing differently as different faces of it face the sun. Certainly looks like it's zigzagging. Very weird. Very weird indeed. We'll also show stereo A, which barely shows the comet. Here's where it's located, by the way. You'll just see a little bit of a blur over here eventually. It does show up on the difference imagery as well. Just not super clearly. And here it is on the raw coronagraph over here. You can barely see it on stereo A. Not super helpful. Our custom coronagraphs are a little bit helpful. There's a pretty good view. It could just be breaks in the data creating an optical illusion. I don't know. Looks a little strange. Looks a little strange to me. I don't know. Let us know in the comments what you think. There's a pretty good frame. Why it won't pause there, I have no freaking idea. Okay, never mind. We'll just move on. Here we've got difference imagery in 193 angstroms. And here we've got just the 193 angstroms and its own difference imagery together. I thought that's pretty cool. Let us know what you think, and let us know what you think, and it's time for filaments. So, and I don't know what's going on with Cerro Tololo's grayscale imagery, but it's really small now, a lower resolution for some reason. Whatever. We've got some massive filaments indeed, and the one that one of our viewers named after me right there is looking pretty unstable. The Lance Armstrong is looking massive. And the Bill Maher filament is setting down here in the southwest. We've got more large filaments up here in the northeast. And one back here, right moving into center solar disk. So that one might be a good idea to name after somebody. Name filaments after living people. Follow the hashtag NameThatFilament over at x.com, otherwise known as Twitter. Twitter.com/SmashoMash. Here are the past few hours from the GOES 16 SUVI. And things are pretty calm, and let's move on to... I'm back. Bonus features. First, satellite charging hazards. We ain't got none. It's smooth sailing for satellites here. No surface or internal charging hazards. Electron flux has been kind of high. It looks like it's maybe reached a peak here. Those are the past 3 days. There's the past 1 year. And we do have the highest levels since around Halloween. There is the forecast. NOAA expecting a dip in the electron flux. I have no disagreements. Although it is expecting it to be largely flat by tomorrow's update. We'll also show the layer where it's measured. The F layer. It's the bridge between Earth and space, folks. There it is. The F ionosphere. It's located at approximately 300 kilometers of altitude. And things are looking quite normal in that location. There's the anomalygram. Just in case the raw megahertz imagery is Greek to you, that should help. Anomaly in megahertz from a 30-day median. And a great example of how the South Atlantic anomaly stands out, the weakest point in Earth's magnetosphere, right there. Right over the center of the South American continent. There's the latest image, that's 2300. We'll also show total electron content after we show the WAM. Last Christmas we didn't show this, but this year we did, so you don't get pissed. This year, to save you from fear, we'll show you the total electron content and the maximum usable frequency. Yep, things are looking pretty normal. There is absolutely nothing to be spooked of there. So let's move on to just the total electron content by itself. Feel free to pause the video in this frame if you're not familiar with distances in miles. Here is the CTIPE, the coupled thermosphere, ionosphere, plasmasphere, electrodynamics model. And those would be where the refraction of your GPS signal would be most likely to be occurring. We'll close out space weather with the latest in continuum and magnetogram. I said it before, I'll say it again. This area right here is the most likely place to see a large solar flare. The northwestern limb, followed by the southwestern limb. Those are the two spots to watch. And now it's time to get to meteorology. So we've got a low pressure system that's largely controlling things over the U.S. And that is a large channel of low pressure air there, stretching all the way from central Mexico all the way up to the Minnesota-Canada border. So that is where all the air is being pulled. We've got high pressure on both sides. You've got a relatively speaking high pressure over here. You've got a relatively speaking high pressure over here. And then you've got this area of low pressure. And that's what's controlling the U.S. weather at the moment, bringing some snow to some parts of the U.S., and we'll show you forecasts here in a minute. First, global wind patterns. Those are the surface winds of the east, and these are the jet streams. These are the jet streams of the central world, and these are the surface winds. These are the surface winds of the Americas, and these are the jet streams. This is clouds and fog over the Americas. As we zoom in closer and closer to the lower 48's weather. There's a low moving into New Mexico, and here's a close-up of it. Just having recently crossed the Arizona-New Mexico border, that low now is mostly in New Mexico. It'll be making a hard left and traveling right up the Rockies. You can see a bit of a clockwise rotation there and some significant atmospheric mixing happening. And here's our precipitation type. Again, we've got snow falling in some places and rain in others. So the northern Rockies are getting snow. Arizona and New Mexico, mostly rain there with some wintry mix. And by the way, there's some ice storm coming up in the forecast. We'll get to it here first. The weather.gov map. Weather.gov is where to get your weather alerts if you are in a location that's lit up on the map. Weather.gov, the homepage for the National Weather Service. And we'll start out our forecasts with the next 72 hours for pressure and precipitation. Again, there's going to be an ice storm in northwestern Iowa, also parts of Nebraska. So right at the rain-snow line, there's going to be some rain falling on some very cold areas, which is the recipe for freezing rain. You get warm air and cold ground and some rain glazing on there, and look out. And that low is just going to loiter over Nebraska. It's just going to kind of hang out there for a day. So that will change things quite a bit. Here is our accumulated positive snow depth change. That'll show you where the places are likely to be having a white Christmas. And guess what? Nebraska and South Dakota especially. You will have a white Christmas because some pretty heavy snow coming there, pushing 2 feet in some areas. But more like 10 inches in most of those heavy regions. Also the Rockies and the Pacific Northwest expecting some snow, a little bit in New England and New York, and a tiny bit in Pennsylvania. Here's temperature anomaly forecast in degrees Celsius. And it looks like we've got some warmer temperatures coming to the east. By the 26th, it'll be mostly west of the Mississippi Valley. Temperature anomaly in degrees Celsius, the GFS 72-hour model. Couple more things. Lightning. That's the past about 10 hours. Quite a bit of lightning in South America there. And here is lightning for the past hour from lightningmaps.org. And we do have some current strikes here in parts of Texas. So Midland has got some activity there. Also north of Lubbock and around Amarillo. When I drove across the country, this is actually the route that I took. And we stayed at Amarillo. Talk about some polite folks. You want to see some polite people, visit Amarillo, Texas. People are just downright nice. Or at least they were to me. Anyway, lightningmaps.org is where to get a real-time lightning map. And by the way, if you enjoy the content, don't forget to press the like button. Yeah, press the like button. That would help. You know, like if you're new to the channel, press subscribe. If you want the world's most comprehensive daily space weather show and detailed solar imagery, there's no competition. There are people doing different things, but I don't think anybody's able to do the same thing. So, yeah, good luck. Good luck. We encourage you to study the sun. And we encourage you to press the like button. Thanks to everybody who has. Thanks to our new subscribers, etc. Thanks to the Smash Team. SmashOmash.com/Smash Team is our subscription services site. We made our own because Patreon couldn't contain us. SmashOmash.com/Smash Team. Click log in, and then click posts to see the posts for your level. Today's featured product is being worn by me right now. Yeah, it says do the math. Yeah, it's there you go. Do the math. The red classic t-shirt there. Save some dough by buying in bulk, by the way. Do the math. We showed the work. 8 equals capital D. Hopefully you don't suck at math. You know what they say, if you want something done right, do it yourself. Maybe consider doing the math. And a consumer tip. If you see people making extraordinary claims on YouTube videos about science topics and they show you science papers, read the abstract and the conclusion of the science papers. If it's saying something opposite of what they're saying in their video, it's probably because they either don't read it, don't understand it, or both. Please do the math. 8 equals capital D. And don't forget to check out our gift items. Yeah, you want to get some therapy? Yeah, how about some red light infrared therapy? Yeah, to get you through those long, boring winter months. Do you work remotely and never see the light of day for 3 days at a time? Well, consider some red light therapy. You can do your remote job with a red light shining on your face. It's super good for you. Increase circulation. Age in reverse. Amazon.com/shop/SmashOmash. Amazon.com/shop/SmashOmash. You can also find a link to our Hemp Lucid shop below this very video in the description. Just click on that, and once you've picked out the items that you want to purchase, on checkout, enter the promo code SmashOmash10. It'll save you 10% on your Delta 8s, on your pet CBDs, on your sleep mushroom gummy body balm, CBD tinctures, and all the rest. Save 10% with the promo code SMASHOMASH10 at hemplucid.com. Again, ask a particle physicist a question via our forum if you like. You can find it at smashomash.com/forum. And welcome to the Neo-Renaissance. We saw the writing on the wall back in 2019 due to pathetic, putrid, disgusting, ridiculous, evil, fascistic, and not very well-administrated censorship on Facebook. We hope your servers burn. SmashoMash.com, the official homepage of the Smash News Network, least busted name. In news, we're closing out the video with U.S. Doppler radar. Quite a bit of precip across the lower 48. There's the full map. Clouds and fog, as that low is already starting to turn to the north from that flow in Texas. You can see this low is effectively pulling things toward it as the atmosphere tries to reach static equilibrium. Here's a recap. U.S. Doppler radar. It shows vertical motion in the air column. Could be snowing here in Pennsylvania. Gotta go check. Here is clouds and fog depicted by shortwave radiation satellite. 3.9 micrometers infrared. 6.61 micrometers infrared is the water vapor map. It shows the dry air, the moist air, and all in between. And I'm in between going to chill back in the bunker, where it's nice and safe. I can be all safe from all this spooky, spooky space. Anyway, see you soon, and make sure you don't let me touch you, because I melt all within my clutch. I'm too much. Bye. Magma chamber, here I come. Whoa.